Hello everyone, welcome to the YouTube channel. Today in this video we'll mainly discuss about carbohydrate chemistry. So here we'll discuss about the definition of the carbohydrate and also classification of carbohydrate. Introduction. Carbohydrate is one of the important biomolecule. It is required for various activity our body will do. So even for the very simplest activity, it may be for sleeping or it may be for walking, all the activity we are doing will require energy. Our body will mainly obtain this energy for all this activity mainly from the carbohydrate only. So they are widely distributed in the plants as well as in the animals. Some examples for these carbohydrates are glucose, fructose, lactose, maltose, sucrose, and starch. So coming to the definition, carbohydrate can be classified or the carbohydrate can be defined as polyhydroxyaldehydes or ketones or the compound which will give them on hydrolysis. Here we are having the structure of glucose as well as the structure of the fructose. So in this structure we can see the glucose is having multiple hydroxyl group. So along with that the functional group that is present here is aldehyde. So that is why we are calling it as a polyhydroxyaldehyde. So while coming to the definition, the carbohydrate can be defined as polyhydroxyaldehyde. Okay, or it can be also defined as polyhydroxyketone. So here in this structure, this is the structure of fructose. Here the functional group is a ketone instead of aldehyde. So if the structure is having the ketone, we are calling it as a polyhydroxyketone structure. Again, we'll go back to the definition. Carbohydrate can be defined as the polyhydroxyaldehyde or polyhydroxyketone or the compound which will give them on hydrolysis. We can mainly classify this carbohydrate into four main types based on the number of the carbon unit that is present. If the structure is having a single unit only, we will call it as a monosaccharide. The first one is monosaccharide. If the structure is having a single unit, we will call it as a monosaccharide. So second one is disaccharide. If the structure is having a two monosaccharide unit combined together, we will call it as a disaccharide. So these disaccharide will require a bond to held together. So here one bond we can see, right? So this particular bond is called as glycosidic linkage or glycosidic bond. Here, the third type of classification is called as oligosaccharide. If the number of monosaccharide unit is between 3 to 10, we will call it as a oligosaccharide. So here in between the 3 to 10 molecule, again there will be glycosidic unit will be there, or the glycosidic bonds will be there between individual monosaccharide unit. The fourth type here is polysaccharide. If the structure is having a multiple monosaccharide unit, if it is having more than 10, we will usually call it as a polysaccharide. So coming to the classification, it can be classified into mainly four types as monosaccharide, disaccharide, oligosaccharide and polysaccharide. Coming to the monosaccharide, this monosaccharide can also be called as a simple sugar. So it cannot be further hydrolyzed since it is a very smaller or the very simpler structure. It need not to be hydrolyzed further. So it can be directly absorbed in the body. Monosaccharides are also called as the building blocks for the higher carbohydrate, like for the disaccharide, oligosaccharide, polysaccharide, all other types of these carbohydrates are made up of this monosaccharide unit only. Coming to the general formula or empirical formula of this monosaccharide, we can represent it as CnH2nOn. The example here for the glucose, we can give it as a C6H12O6. So again, this monosaccharide can be classified mainly based on two ways. The first one is based on number of the carbon unit they are processing, and another one is based on the functional group they are having. Okay, this monosaccharide can be classified into mainly two ways. First one is based on the number of carbon atom that is present in the structure. Second one is the presence of the functional group, whether it is a aldehyde group or whether it is a ketone group. So based on the number of carbon atom, this monosaccharide can be classified. It will mainly start with a 3 carbon structure. Okay, if it is having a 3 carbon, we'll call it as trioses. 4 tetroses, 5 pentoses. 6 means we will call it as a hexoses. So depending upon the functional group, if it is having a aldehyde group, we will call that sugar as aldose sugar. So if it is having a ketone group, we will call it as a keto sugar or ketosis. So here is the basic example. The trioses, usually they'll be having the 3 carbon atom. If you remember the structure, the empirical formula of the monosaccharide, it will be CnH2nOn. The C is 3 here, 3 into 2 is 6, again it will be 3 only. Okay, so if the triose is having a aldehyde group, the example for triose is containing aldehyde is glyceraldehyde. The trioses that is containing a ketone group is dihydroxyacetone. Tetroses, erythrose, erythrulose. Pentoses, ribose, ribulose. Hexoses is glucose and fructose. So based on the functional group, this this monosaccharide can be again classified as the aldoses and as ketoses. Some example for the aldoses is again the glucose, galactose, ribose. Some example for the ketoses are mainly the fructose, ribulose and xyloses. So here one thing you have to remember, aldoses will always contain a aldehyde group in it, where the ketoses will contain a ketone group in it. The ketone will be represented with the C double bond O, and aldoses will be represented, or aldehyde group will be represented with the CHO group. So next one is about disaccharide. Disaccharide means if the structure of the carbohydrate is containing the 2 monosaccharide unit. So again it cannot exist independently. It will require some force to held together. Okay, the 2 monosaccharide units are held together by a special bond that is called as glycosidic bond. Here in the structure we can make out if 2 monosaccharide units are bounded together by particular bond, we'll call it as a disaccharide. So here this particular bond is called as glycosidic bond. So they are usually crystalline in nature. They can be easily water soluble and they'll be having sweet taste. Again coming to the general representation. So the general representation here is CnH2n-1. So it is also called as empirical formula of disaccharide. So disaccharide can also be again further classified into 2 ways. First one is called as reducing disaccharide, another one is called as non-reducing disaccharide. If the free aldehyde of the keto group is present in the structure of the disaccharide, we will call it as a reducing disaccharide. Example for this one is maltose and lactose. If there is no free aldehyde or the keto group attached in the structure, we will call it as a non-reducing disaccharide. Example here is sucrose and trehalose. So these are the two examples, two types or the classification of the disaccharide. These disaccharides are mainly composed of monosaccharide unit only. So here is the basic example. The maltose, sucrose, lactose, these three are the example for the disaccharide. These three structures are made up of the single monosaccharide unit only. If two molecules of the glucose are combined together by the glycosidic bond, we will call it as the maltose. If one glucose and one fructose is combined together with a glycosidic bond, we'll call it as a sucrose. If one glucose and one galactose molecule is combined together, we will call it as lactose. So these are the basic component of individual disaccharide. So this thing you have to remember, disaccharides are always composed of monosaccharide unit only. Maltose is having 2 glucose unit, sucrose is having 1 glucose and 1 fructose unit, where the lactose structure is having 1 glucose and 1 galactose unit in it. So oligosaccharide means it is also a type of the carbohydrate. If the number of the carbon unit that is present in a carbohydrate is varies between 3 to 10, we will call it as oligosaccharide. Again, the bond that will held together all the monosaccharide unit is called glycosidic bond or glycosidic linkage. So these oligosaccharides will be mainly present in the cell membranes. Blood group antigen are also the oligosaccharides only. So example for this one is maltotriose, raffinose, stachyose and verbescose. These are some of the example for this oligosaccharide. Coming to the polysaccharide. The polysaccharide is a fourth type of carbohydrate. Poly, in the name only it is there. Poly means multiple. So if more than 10 monosaccharide units are bounded together or held together, we will call it as a polysaccharide. So polysaccharides are also called as glycans. The general representation for these glycans are C6H10O5 whole bracket N. So this is the basic representation of this polysaccharide. So you have to remember polysaccharide will be having multiple monomeric or monosaccharide unit. Again they will be held by the glycosidic bonds only. Okay, so it is having one more name that is called as glycan, glycosaminoglycan. These are some examples. Coming to the classification of polysaccharide, these can be classified into two ways. One is homopolysaccharide and the one is a heteropolysaccharide. If the carbon atom or if the monosaccharide unit, if all the monosaccharide unit that is present in a polysaccharide is of the same type, if one molecule is glucose, if entire thing is made up of the glucose only, we'll call it as a homopolysaccharide. If in the structure, if it is having a different monosaccharide unit, one is glucose, another one is fructose, one more thing is galactose. So if all these things are combined together, we will call it as a heteropolysaccharide. Coming to the homopolysaccharide, homopolysaccharide can also be called as homosaminoglycan or homoglycan. Polysaccharides, which are made up of only one type of monosaccharide unit, is called as homopolysaccharide. Some example for this homopolysaccharides are mainly starch, glycogen, cellulose, and inulin. Okay, so this thing you have to remember. Inulin is different as well as insulin is different. So the homopolysaccharides, the example for this homopolysaccharides are mainly starch, glycogen, cellulose, and inulin. So coming to the structure of the starch, starch are mainly made up of two important components. One is amylose, another one is amylopectin. So these two are the component of the starch. So amylose are always, it is having a straight structure, straight chain structure will be there. The bond that is present between individual molecule of the amylose is the alpha 1,4 linkage, where amylopectin will be having a branched structure. So wherever there will be branching will takes place, it will be having alpha 1,6 glycosidic linkage. Some sources of the starch. So this starch item will be mainly rich in potatoes, tapioca, cereals, and some other food grains. Okay. So here in the structure we can make out the starch is mainly made up of two components, and one is amylose and another one is amylopectin. So this is the structure of the amylose. It is having a straight chain structure. The bond between individual molecule is called as alpha 1,4 linkage. So here we can see the another structure that is called as amylopectin. So wherever there is a branching we can see, so those are the alpha 1,4 linkage. Rest the straight chain whatever we are seeing, they'll be having alpha 1,4 linkage only. Second type of polysaccharide is heteropolysaccharide. So it is also called as heteroglycan. If polysaccharide is made up of more than one type of monosaccharide unit, we will usually call it as a heteropolysaccharide or heteroglycan. This heteropolysaccharide, it will be mainly present in the human beings. Is called as the glycosaminoglycan, or it can be also called as a mucopolysaccharide. Some example for this the heteropolysaccharides are mainly heparin, chondroitin sulfate, hyaluronic acid, dermatan sulfate, keratin sulfate, blood group, polysaccharide, and agar. So we'll summarize the carbohydrate once again. The carbohydrate, so we can mainly classify this into two main category. One is a simple carbohydrate and another one is a complex carbohydrate. Under simple carbohydrate, we'll be mainly having monosaccharide and disaccharide. Under complex, we can classify oligo and polysaccharide because of its complex structure. Okay, so the monosaccharide can be further classified into two ways, so that you have to remember, based on number of carbon atom. Another one is based on the number of the functional group that is present, whether it is a aldehyde group or ketone group. Under disaccharide, we can classify the disaccharide mainly into two types. One is reducing disaccharide, another one is non-reducing disaccharide. If it is having a free aldehyde group, it will be reducing disaccharide. If it is having no free aldehyde or ketone group, it will be called as non-reducing thing. Under oligosaccharide, we are not having any further classification, but for the polysaccharides, we have two more classification. One is a homopolysaccharide, another one is called as heteropolysaccharide. So this is about the definition and classification of carbohydrate. I hope this video is easy for you to understand. Thank you for watching.